Today.
All right, we're going to talk about arithmetic sequences. And just in general, what a sequence is. We're changing direction here. Our vector is changing course. All right, so we have to talk about, by definition, what a sequence is. All right, I'm going to write a sequence up here. First of all, a sequence is a collection of items in a certain order. Now, in our case, our sequence is going to be numbers. Okay, and this sequence consists of the numbers 3, 5, 7, 9, and this one is an infinite sequence because of the comma, dot, dot, dot. So this here implies an infinite, a sequence. And so then you can also have sequences that are just finite. Sequences have a domain, believe it or not, and a range. So the domain of a sequence is the position you are in the sequence. For example, this is in position 1. This is in position 2. This is in position 3. This is in position 4. So the domain is the position, and it's typically the counting numbers. I cannot spell, it's Monday morning. The natural numbers. You notice that the 3 is in position 1. The 5 is in position 2. And you can't really be at position 1.5. Okay? So sequences are not continuous. They are what we call discrete, meaning it is not continuous. It's got a whole bunch of stuff in between. I mean, between 3 and 5, there's an infinite gap here. Okay, so it's not continuous. What about the range? This is going to be the numbers in the sequence, yes. All right, and typically what we will do is we will call this a sub 1. That meaning sub, that means the 1 is below, it's not an exponent. A sub 1 means this is in the first position. A sub 2 means this 5 is in the second position. A sub 3 means that 7 is in the third position, and then A sub 4 means we're in the fourth position. Now this sequence is a special kind of sequence because could you predict what the next term would be? We have 3, 5, 7, 9, 11. So what are you doing to get to the next term? We're adding, right? And that means this is called an arithmetic sequence because we have a common difference. Common difference being 2. The difference here is 2 every time. And this is called the common difference. And we like to refer to that as D, believe it or not, for difference. So then by definition, an arithmetic sequence is a collection of numbers with a common difference. D. All right, so let me ask you this. What if I were to ask you what the 1,000th term was? I don't want to mess around with terms 8, 1, 2, 3, 4. I want to know what the 1,000th term is, the 1,000th term. Yeah.
Would it just be multiply 1,000 by 2?
Okay, so 1,000 by 2 is 2,000.
And then add the first one.
Okay.
I think it's 2003.
So shall we check?
I guess.
All right, so how can we do that? Can we figure out something called an nth term? Meaning a term that's in the nth spot. Meaning if I know what n is, I have some kind of formula to figure it out. The answer is yes. So let's see how that works. For an arithmetic, finding the nth term. The nth term, we're going to call it what? A sub n. All right, so the first term in a sequence is obviously a sub 1, right? I mean, that's easy enough. How do we get to the second term using a sub 1? In this case, we added 2. All right, what do we call that, though? We're going to take the first term and add 2, which is the common difference, right? So then what do I do then to get to the third term? I take the second term and add the common difference again. So I'm going to take this, which is a sub 2, a sub 1 plus d, add another d, another for common difference, and then a sub 4. What am I going to do? I'm going to take a sub 3 and add d. So that's going to be a sub 1 plus d plus d plus d. Then a sub 5. We're going to get a sub 1 plus d plus d plus d plus d. I'm going to make a big leap here. What's the first one going to be? I mean, the first term to the right here is obviously going to always be, everybody see that? Plus, and that's right, n minus 1 times d. Very nice. Because if you look back at our calculation here, there's 1d here, there's 2 D's. There are 2 D's here, there are 3 D's here, and there are 4 D here. And it appears as though it's always 1 less, right, than where you're standing. Everybody agree with that? That's good. So let's come up with then an nth term for our sequence above. What did we have? We had our sequence was 3, 5, 7, 9, ... And we want to find a sub n. Now, with this is the general formula for the nth term for an arithmetic sequence. Now, arithmetic means what again? Arithmetic sequence means you're adding or subtracting. You have a common difference. What is the common difference here? 2. And what is a sub 1? Can we see it? A sub 1 means that it's the number standing in the first spot, which is 3. So this is going to be 3 plus n minus 1 times 2. Now, this is similar to the equation of the line. When we had y equals mx plus b, what did we have to have filled in? We had to have y equals mx plus b, m filled in, and b. With the general formula for the nth term of an arithmetic sequence, we have to have what filled in here? A sub 1 and d, because that's what makes a sequence a sequence. It's having a starting point and a common difference. Okay, so could I figure out now with ease what the 1000th term is? And we're going to see if John's right. We can say a sub 1000 equals 3 plus 999 times 2. And you math whizzes are going to calculate this for me and see what we get.
1998.
When you do add the 3 also? John, you were close.
I made 1 less.
Yeah, that's a nice shortcut to have, isn't it? Short of writing out 1000 terms and adding 2 every time. Right? This is the explicit formula. Now, what do I mean by explicit? That means if I tell you what n is, you can tell me what the number is in that spot, in that sequence's spot. I can also have a definition that's defined recursively. Now, ooh, that's a big word, recursive. And that doesn't mean rewriting in cursive.
I can know your word.
What's that?
Flabbergasted.
Flabbergasted. Okay. Recursive means where I'm standing is going to be dependent upon the term in front of me. So what do I do with the term in front? If I'm standing at a sub n, what is the term that's in front?
A sub n minus.
That's good. A sub n minus 1 plus d. That's the recursive definition. The problem with the recursive definition is I have to know the term
Recursion.
in front. I would have to know term what here? In the 1000th case, I'd have to know the term 999. Now that's problematic, right? So this is the recursive definition. I just want you to be aware that that's out there. Okay, so let's do an example. let's say we have a sequence. 50, 44, 38, 32, comma, dot, dot, dot. First of all, this is infinite. We want to find a sub n. And a sub 20. So we want to find the formula for the general term, which is a sub n, and we want to find the term that is sitting in the which spot? 20th spot. So the formula is a sub n equals, if we go back, a sub 1, good, plus n minus 1 times d. I have to check to see if this is arithmetic. Is it? Let's see. 50 to 44 is negative 6, and then 44 and 38, the difference is negative. You see how it's negative 6? It has to be negative 6 for every term that you see. If it's not, then guess what? It's not arithmetic, and we can't use this formula. Okay? All right, so you guys were very smart and said that d is negative 6, and a sub 1 here is 50. So what can I do here? I can say a sub 1 n is then 50 plus n minus 1 times negative 6. Now you'll see some books will simplify this for you, but I don't mind if you leave it like this, because what are we about to do? We're going to find a sub 20, which means I'm going to do what? It's so much easier to do this than when it's distributed, okay? So this is going to be 50 plus 19 times negative 6. All right, you calculator whizzes.
Negative 64.
Negative 64. So in the 20th spot, we have negative 64, and this is our a sub n. That's pretty easy to do, right? So guess what? Your calculator will also do sequences. Who knew?
You did.
Well, okay, maybe I did. So let's pull out our calculator. And we're going to change the mode. Oh my goodness, there's function, parametric, polar, and sequence mode. And so then what happens when you press y equals now? That happens. Well, that looks a little bit weird, doesn't it? Now, n min here means a sub n. We're going to start with the first term. So we don't mess around with that very much. So what was the rule we just came up with? 50 plus parentheses, right? And what happens when I touch the X key now? N minus 1 times negative 6. And we're going to put let me see, second table. What's going on here? Oh, it doesn't like that, does it? Window. Let's set our window. N equals 1. Oh, we want our step. Okay, so let's make our X min be 0 and our X max be 50. Or actually, our X min is going to be 1 because that's. And y, let's make that negative 5 to, oops, I'm sorry, negative 5 to 60. And then y equals, and then we're going to let n min this equal 1.
What is that?
Oh no, that actually that means our first term, right? With this new version of this calculator, I think that's your first term.
Well,
No?
well, I got a question.
I know you do. Yours is very different.
Yeah.
So second table. Let's see if it starts. No, it doesn't like that. Why do I have my n
It does
as?
it for us.
I understand that. Let's see here, window. My n step. What? Works for you. Why is mine? Huh. Second table set. Oh, look at where I have my table starting. At pi over 2. Is that helpful? No, I'm going to have my start at, and then I'm going to make my table setting 1 here. It helps when I have my table set upright. Now, why was it showing an error? Let's ask you that. Because do I have any numbers between position 1, 2, 3, 4? I don't, do I? Because sequences are not continuous. All right. So does your calculator show you the sequence here over here? That's nice. Ryan, does yours?
Yeah.
Okay. Now, there's also a sequence command. Now, how do I find the sequence command? I believe it's under the matrix. Under matrix. Yours is just going to be SEQ parentheses. And then we're going to do some math with it. And hold on a minute. Or would it be math and I'm in sequence mode? I'm sorry, folks. I'm used to the 89. Second list. Ops. Second list. It's second list. I'm sorry, it took me a minute. Second list, and we're going to do some operations with our list, okay? And we're going to get what you spoke. Sequence number 5. You're going to go to the matrix menu. Or list menu. I'm sorry, list menu.
Second step.
All right, so I'm going to hit number 5.
Okay, no, I'm lost.
And number.
Okay, so I'm going to clear this, and I'm going to type this in. John, come up and type it in.
So now I'm doing it.
And now you're going to type in your nth term, which is 50.
I don't know what it is.
Wait, 50, you're typing in that equation?
Okay. I need to update your software.
Well, I did the.
You just have to
John, you're going to type in what our nth term was. What was it, 50? Use that ops, number 5. Huh, that's weird.
And I just cleared it. So
All right, well, I guess I'm going to have
What's
to do
the-
some research on this new operating system.
-6, right?
Oh, okay. Why don't we do this instead? How about we get out of, so close your table. You know how to do that?
There's more than this.
No, yours I have already your software.
Oh, okay.
Did you find it?
Well,
Okay, that's good. Close, arrow over,
Whatever regular is.
and then put comma, n. So you're going to go alpha n, comma, where are you going to start? From 1?
sure.
2, how many times do you want to see? 20. Why don't you do 20? So we see
So
20.
1, 20?
Yep.
Feel like it's.
Yeah, I just.
Thank you, John, for typing this in. Everybody get this screen after you close the table. Yes? All right. So then we're going to start where? It's at 1. And we're going to stop at, let's do 20, shall we? So we can see what our 20th term is. And we're going to do our step of 1 here. And then we're going to press enter and paste. So what happens is it actually does the sequence command. It fills it in for you. All right. And then I'm going to press enter. And then guess what comes up here? Did yours come up?
What would we,
I'm sorry.
what did we put for
So you're
variables?
gonna do your nth term, which is
What did
50
we put for
minus,
variables?
or plus, I'm sorry,
Oh,
n parentheses.
I don't have any more.
No, I'm sorry. You were listening to me. Parentheses, n minus one
Why?
times -6,
Why?
comma,
So,
and
you just press this button.
comma, where do you want to start? We'll start at 1.
Oh, yeah.
You're gonna
Let's-
put comma
what do we
1,
do? Start 50.
We'll start.
1,
And then
comma,
and is gonna be what?
20, we'll end at the 20th.
20.
Close. And then press enter.
Oh,
Just start at
no,
1.
you
Just start at 1 or start at 50?
1, start at 1.
Start at 1, because that's 4.
It's end at 20.
Right, now, you'll notice what it comes up in parentheses, or I mean, a different kind of set of parentheses, doesn't it?
Yeah.
It's the curly braces. Okay, let's say I want to see the 20th term because I can't see it, can I? From here? So what do we have to do? We have to arrow over, I hope. Maybe. My calculator's not cooperating. I'm going to do it again. Here we go. Enter. Enter. Oh, you have to be down here and arrow over. That's so silly.
Nope, that's still not working.
I got -64. Did we get -64 when I scrolled all the way over? Yours is not working?
Just press enter like she did again, and then.
But how do you count that many?
It's going to be the last one, isn't it? Because,
Oh, true.
right?
Oh, thank you.
Scroll over that way. Okay, it's going to be the last one because we went to 20. Right? Now, let's say I wanted to see the 20th term without doing all of that nonsense. I would go second list, ops,
There you go.
sequence, and then I'd start at the 20th term and end at the 20th term. If you start and stop at the same term, guess what happens? Well, I don't want to graph. I want to press enter. And what do we get? Oh, wait. Second list, ops, number 5. It's gone now. 50 plus parentheses
And
And-
-1.
-1
Parentheses,
times
-6.
-6, or you can use parentheses if you like. Variable is n. I want to start at 20.
Start at 1.
I want to end at 20, and I want to have a step of 1.
Wait, I thought you
Start
were
at
starting at 1.
No, I want to start at 20 so I can see the 20th term without having to scroll through.
Oh, okay, so it's now.
You can start and stop at the same spot. Everybody got it?
But what if you like to get it clicking?
You can do that too, John, if you like. Okay? All right, that was just a quick intro.
Thank you.
What if I was given
Not that was the most memorable. It was the best 5 years of my life. And
Gonna say.
Yikes. Thank you, I appreciate it. And that hair. Because I had to cut it.
Like right before school?
Yeah. I only had it for my senior picture. And that was it.
Here we go. This is in order for you to be able to do your homework. All right?
Homework.
Find the general n term given. Let's say you don't have a sub 1. And goodness gracious, you don't have d.
Oh, God.
And what have I given you instead? I've given you
2 terms.
2 terms. So in a way, I've given you 2 different n's. So we can say n equals 6. And when n is 6, we have a sub 6 equals a sub 1 plus
5.
5d, right? I mean, I can use the n minus 1. But what is a sub 6? 10. So I can say 10 equals a sub 1 plus 5d. What about
We just,
system?
system, yeah.
So this is going to n equals 21. So what happens? I've got a sub 21 equals a sub 1 plus 21 minus 1, which is 20d. But a sub 21 is 55. So then I get a sub 1 plus 20d. Now, this is a system. What's really nice about this system is that there is always a 1 in front of the a sub 1. Isn't there? So combination works brilliantly. So we can say 10 equals a sub 1 plus 5d, and 55 equals a sub 1 plus 20d. Now all I have to do every time is multiply one of these equations by -1. And I'm going to choose the first one just because it happens to be first. Is that all right? And what do we get here? -10 equals negative a sub 1 minus 5d. I'm just rewriting the second one for ease of addition. And now I can add these two equations together. And we get
45.
equals, and these go away,
15.
15d, and d is equals to 3. So how do I find a sub 1 now?
Plug it back in.
You plug it back in. I'm going to choose the first one since it's got smaller numbers. Okay, and then we can say substituting. We can say that 10 equals a sub 1 plus 5 times 3. So 10 equals a sub 1 plus 15. So a sub 1 equals -5. So my general nth term is going to be -5 plus n minus 1 times 3. And now I can find any term in that sequence. All right, we got 5 minutes. I'm going to let you guys try one. Go. Yeah. No, that's all right. I'm going to post all these. So you'll have all of them on. Thank you. Yeah. That was a little rushed because I should have spent less time on the test corrections. But it is what it is. What?
Does this have the longer announcements earlier on?
Yeah, it is a little bit longer. You're right. Most people like this because it's very algebraic. can extend the page. Oh, you can do it there, that's fine, that works too. Good, now extend the page down to the bottom, the little blue thing, yep, and then write your A sub n, that's great. Everybody get that? Pretty simple, isn't it? Okay, now there's one thing on the homework that might be a little bit confusing, so I'd like to show you real quick, but it's not difficult, but people look at it sometimes and just go, oh my, I don't know what that means. We're in chapter 9. Point 4. We're skipping the probability stuff. Okay, here we go. Please tell me you made it. This one right here. Now, I only assign one of these. Now, not every sequence is arithmetic. That makes sense, right? It might have some other pattern. So, in exercises 1 through 4, it says find the first 6 terms and the 100th term. And they're giving you a bunch of letters, U sub n. Now, I said A sub n, but you can also, it's also defined using the curly braces, but you can use all sorts of letters to represent what a sequence is. And in our book, it uses U sub n, C sub n, B sub n, D sub n. Now, the most common, A sub n and U sub n. But I think they just wanted you to be familiar with that. So let's do number 2, which says write the first 6 terms. So that means let n equal 1. So I'm going to do 1, 2, 3, 4, 5, 6. So what happens when I let n equal 1? 4 over 3. Boom. N equal 2. 1. N equal 3. 4 over 5. You see what we're doing? So that's not scary. So this is n equal 2. This is n equal 3. Help me with n equal 4. 4 over 6, which is 2/3. N equal 5. 4/7, and then 1/2. And then obviously it keeps going, but they just want the first 6. That's easy enough. And then they want the 100th. So they want B sub 100, which means we're going to put 4 over 102. What is it?
2 over 51.
2 over 51. I agree. That's all there is to that first part of the homework. So don't let it intimidate you, okay? Next part of it. What does the list say? 3, 5. They just ask you to find the terms. I think you can do that. Let's do a recursively defined one. Let's do number 6. Find the first 4 terms of a recursively defined. Recursively means defined by the previous term. Very nice. Let's do number 6. Number 6 says U sub 1 equals -3 and U sub k plus 1 equals U sub k plus 10. Now that just means, I had it worded the other way, but it doesn't matter, right? So we want the first 4 terms. So they're telling us the first term is -3. How do we find the next term? We add 10, which is 7 plus 10. 17 plus 27. And then they want the eighth term. Well, what do we have to do to know the eighth term? We need to go to the seventh. Do you follow how to do this? Not difficult.
How do you go to 7?
What?
How
They want to know the eighth term, right? So we have to go, this is what term? 1, 2, 3, 4,
I see. You
5,
have to do it
6, 7, 8. Yeah, you have to keep doing it until, that's the problem with recursive, is that you have to know the term before. Which is a pain in the neck if you want to go to 1,000.
You have to go all the way down.
Right, exactly. So, all right, and then let's see. And I can do the rest because that's more of a systems kind of thing. All right. There we go.
Oh, I want to get here.